Hello, my name is Marisol Loza. For this project, I decided to focus on speed of light. On the first slide, you see pictures of my classmates in the same group as me. Some basic facts. The speed of light in a vacuum denoted by cc is exactly 299,792,458 meters per second, or about 300,000 kilometers per second, making it the fastest speed in the universe and the base of Einstein's theory of relativity. For example, light can circle the Earth 7.5 times in just 1 second. Some basic definitions: relativity, Einstein's theory that shows how space and time and energy are connected within the speed of light as a constant. Light year, the distant light travels in 1 year about 9.46 trillion kilometers or 5.88 trillion miles. Some basic background: the idea that light had an infinite speed was first proven in 1676 by Old Romer and later refined by other scientists. In 1983, it was officially defined as the universal constant in physics. Some related fields: we have nuclear physics. Einstein's famous equation E equals mc 2e equals mc2 shows that mass can be converted into energy within the speed of light squared, acting as the conversion factor. Speed of light ties mass and energy together, leading modern particle physics. Biochemistry: the speed of light activates energy transfer, detection, and analysis in living systems, making it fundamental to processes like photosynthesis, vision, and molecular research in biochemistry. Relativity relies on the constancy of the speed of light to explain how time, space, and energy and gravity work. Some basic facts about fields: speed of light plays a crucial role in nuclear reactions, biological processes, and in relativity. In nuclear reaction, it explains why reactions release so much energy. In biochemistry, it drives key biological processes like photosynthesis. And in relativity, it links time, speed, and energy through C. For my relevant scientist, I focused on Galileo Galilei. He was born in Pisa, Italy. He is considered the father of modern physics. His studies on falling bodies and inheritance laid the groundwork for Newton's laws. Some educational facts: he studied at the Camaldisa Monastery at Vallombrosa. Later was enrolled by his father for a medical degree at the University of Pisa. Some research topics: Galileo's significant physics discoveries include the law of inheritance, the universal law of acceleration for falling bodies, and the parabolical path of projectiles. Galileo is significantly known as the father of modern physics. His achievements of mastering the experimental scientific method laid the foundation for the work of later scientists.
Dakota Sweeney. That's my. So, for basic facts, light travels from the moon to our eyes in 1 second. Sunlight takes about 8 minutes to reach our eyes. And then basic definitions related to topic. I chose space-time, which is the concept of time and three-dimensional space regarded as fused in four-dimensional continuum, and then vacuum, which is a space devoid of matter, which is where light travels at its maximum speed. And then for basic background, in around 525 AD, a Roman scholar attempted to document the speed of light. He was later beheaded for treason and sorcery. And then related fields, I don't know how to say the field, but the speed of light is a physical constant that is defined by the fundamental properties of electromagnetism and space-time. Its role is limited to applying a mathematical tool in theoretical physics research. And then for basic fact, or how the topic relates, math is used in physics to understand many things. It explores the way of counting, combining, and arranging discrete objects. This helps our understanding of the mathematical way of the speed of light. And then for scientists, I chose Leon. Leon was born in Paris, France. He is a French physicist. Educational facts. He studied at the University of Paris. Research topics. Leon helped get a better understanding about the speed of light and proved that the Earth spins on an axis. And for fame, Leon is best known for his pendulum. It hangs from the ceiling and shows how Earth is constantly moving.
Hello, my name is Andrew Damian. Today we're going to be going over the speed of light. Some basic facts are light can spread out and bend just like water waves, making it a wave-particle duality. Some basic definitions that are related to this is photons, tiny particles of light that carry energy; refraction, the bending of light when it passes from one material to another; and the basic background is the speed of light is how fast light travels through space. In 1728, James Bradley discovered stellar aberration due to the finite speed of light, which created a small change in the position of stars. Some of the related fields are space science and engineering, telecommunications, and the basic facts about these fields is space and science engineering helps us explore the universe by creating new technology, and they use the speed of light to calculate signal delays between Earth and spacecraft such as the ISS, which is in the photo. Telecommunications helps send and receive data such as voice, text, video, images across long distances, and the speed of light limits how fast this information can travel through fiber optic cables. Some of the relevant scientists to this topic are James Bradley, as I mentioned. He was an English astronomer, born in Dorset, England on March 1693, died on July 13, 1762, and he also studied at Oxford in England. He was famous for discovering the stellar aberration with the speed of light and discovered the nutation of the Earth's axis caused by gravitational pull of the moon. Thank you.
The related fields that I picked were photonics. Basic facts about photonics. The term photonics developed as a byproduct of the first practical semiconductor light emitters developed in the early 1960s and optical fibers developed in the 1970s. My relevant scientist was Christopher Huygens. He was born April 14, 1629 and died July 8, 1695. He was a Dutch mathematician, physicist, engineer, astronomer, and inventor who is regarded as a key figure in the scientific revolution. At 16 years of age, studied law and mathematics at Leiden University from May 1645 to March 1647. Between 1651 and 1657, Huygens published a number of works that showed his talent for mathematics and his mastery of classical and analytical geometry, increasing his reach